Hello everybody, today we are going to learn about the Ferrari's method. This method tells us how to solve a bi-quadratic equation. So जैसे you can see, this is a bi-quadratic equation over here. You are going to learn how to solve it using the Ferrari's method. So if you try to use the hit and try method, this bi-quadratic equation won't be solved using hit and try. You can try it for yourself. It won't work using hit and try. So you need to use a proper method. That's the Ferrari's method. So what's in this method? Let's just get straight into it. So basically we keep the x with power 4 and 3 terms on the left hand side and move all the other terms with degree 2, 1 and 0 on the right hand side. So x raised to power 4 minus 2x cube minus is equals to 5x square minus 10x plus 3. Alright, now what we need to do, we need to complete the square over here. On the left hand side we need to complete the square. So x raised to power 4 is x square raised to power 2 minus 2 into a, that is x square, into what is left, x, plus x square. And now this x square is extra that we have added, so we are going to add it on the right hand side also. 5x square minus 10x plus 3 plus x square. Alright, now you can see this is x square plus x square minus x whole square. LHS we get x square minus x whole square. X square minus x whole square is equals to 6x square minus 10x plus 3. Alright, now the next step, this is a very crucial step that you need to take. You just have to add the lambda in this square. So what you need to do, you need to make this term x square minus x plus lambda whole square. Now what will be extra over here? If you expand this, take x square minus x as one term and lambda as the other term. So when you expand this, you will get x square minus x whole square plus lambda square minus plus 2x square minus x into lambda. This is what you will get. So this was already there on the left hand side, as you can see, this is already there, but this is new that is added. So this new thing needs to be added on the right hand side also. So let's do that. Six x square minus 10x plus 3 plus lambda square plus 2 lambda x square minus x. This is added on the right hand side also. Okay, can you understand till now? Now over here, as you can see, this side is LHS is a perfect square. As you can see, the left hand side is a perfect square. So the right hand side also needs to be a perfect square. This needs to be a perfect square, right? So it should be written in the terms like x plus something whole square. This should be of the form x plus something whole square, right? So we'll bring the x square terms together, the x terms together, and the constant terms together. So this is the same, this is not changed. But over here we'll bring the x square terms together. So we have two x square terms, 2 lambda, one has 2 lambda coefficient, one has 6. So 6 plus 2 lambda x square. Now x terms minus 10 and minus 2 lambda. So plus x into minus 10 minus 2 lambda. What are we left with? We are left with 3 plus lambda square. Plus lambda square plus 3. Okay, so we are left with this. Now in this equation, when will this be a perfect square? When will this be a perfect square? Now the condition for perfect squares is that b square minus 4 is equal to 0. Why is this condition over there? if b square minus 4ac equals to 0, then there are two equal roots, right? So there are two equal roots. So if the root is alpha, so the polynomial or quadratic equation can be written in the form x minus alpha into x minus alpha, right? So this will become x minus alpha whole square. So that's why b square minus 4ac should be equal to 0, so that this whole term is a perfect square. Alright, so let's do that. I'll erase this much, right, and this much. Okay, b square minus 4ac equals to 0. So minus 10 minus 2 lambda whole square equals to 4ac. 4 into 6 plus 2 lambda into c, lambda square plus 3. Alright, so now we are going to solve this. So you get minus sign gets cut. So let's say 100 plus 4 lambda square plus 40 lambda equals to 4 into 6 lambda square plus 18 plus 2 lambda cube plus 6 lambda. So I know it seems a bit tedious, but you are going to get the hang of it. It will happen very quickly once you get the hang of it. Okay, so next what we are going to do, we are just going to open this up. 100 plus 4 lambda square plus 40 lambda equals to 24 lambda square plus 18, 36, 72 plus 8 lambda cube plus 24 lambda. Now we are going to bring all the terms to one side. Let's take it to the right hand side so that the lambda cube term remains positive. So let's take everything to the right side. So 0 equals to 8 lambda cube plus 24 lambda square minus 4 lambda square. So plus 20 lambda square left with plus 24 lambda minus 40 lambda minus 16 lambda plus 72 plus minus 100, so minus 28. Now we just need to find one root of lambda. Just need to find one root of lambda in this cubic equation. So we know we can use the hit and try method to find the root, and as we can see, minus 1 is clearly the root. How? Minus 1, this gives us 16 minus 28, that gives us minus 12. Minus 1 over here will give us 20. 20 minus 12 gives 8, and over here minus 1, putting minus 1 will give us minus 8. So you'll get 0. So lambda equals to minus 1 satisfies. Okay, we got the value of lambda equal. We don't need all the other values of lambda. We just need one. Lambda equals to minus 1 satisfies. So we are going to erase all of this and go back to our previous equation. Now we know that lambda equals to minus 1, right? So over here we are going to put minus 1 value of lambda. So x square minus x minus 1 whole square equals to 6 minus 2, 4x square minus 2 into minus 1 plus 2 minus 8, minus 8x, and lambda square, lambda minus 1, 4 plus 4. So now this is 2x minus 2 whole square. Am I right? 2x minus, yeah. So x square minus x minus 1 whole square equals to 2x minus 2 whole square, right? Now we are going to take this on this side, and a plus b, a minus b. We are going to use the property a square minus b square equals to a plus b, a minus b. So we get x square minus x minus 1 minus 2x plus 2 into x square minus x minus 1 plus 2x minus 2 equals to 0. So x square minus 3x plus 1 x square plus x minus 3 equals 0. Solve these two quadratic equations using the quadratic formula, or should I solve it? You can skip this part, but you have got the two quadratic equations. Now you can solve it. From here, x equals to 3 plus minus root 9 minus 4ac, you will get root 5 upon 2. And from here, x equals to minus 1 plus minus 1 minus 4 into this, 4, 12, 13 upon 2. So you get these four values: 3 plus root 5 upon 2, 3 minus root 5 upon 2, minus 1 plus root 13 upon 2, and minus 1 minus root 13 upon 2. And this is the Ferrari's method. A beautiful, beautiful method. What you did was keep the degree 4 and degree 3 terms on the left hand side, put everything on the right hand side, complete the square on the left hand side. After that, after completing the square on the left hand side, add the lambda term inside the square, then add the extra terms on the right hand side, then use the condition b square minus 4ac equals to 0. That will give you a value of lambda. Put the value of lambda into your equation and you are going to get two quadratic equations like this, or you can say two factors. And when you solve these two quadratic equations, you get the values of x that satisfy the bi-quadratic equation. I hope you like the Ferrari's method. It is a very, very good and interesting method, and I'll see you in the next one. Thank you.